So today's lesson, we're going to introduce logarithmic functions. So our learning objective is to write equivalent forms of exponential and logarithmic functions and to write, evaluate. And actually, we're not going to graph logarithmic functions till the next lesson. So whereas subtraction undoes addition and division undoes multiplication, a logarithmic function undoes raising a base to an exponent. So we're going to write logarithmic function here. All right, so what does that mean? That means, so when we're converting from an exponential to a logarithmic, you can write an exponential equation as a logarithmic equation and vice versa. So once you notice here, this is our base b, and that becomes our base over here. And then whatever our exponent was over here, we're going to take it to the other side of the equal sign when we're talking about the logarithm. And then whatever we had on the other side of the equal sign here, that is going to stay to the left of the equal sign here. So when we're reading this math, when we're reading this function here, we say the log base b, this is our base right here, base b of a is x. So notice that the log is the exponent. So as we work some of these, the base of the exponent becomes the base of the log. So as we do this, we're going to write the word log, and we're going to take the base right here, 3, and it's going to become the base of the log. The exponent is what the log is equal to. So the exponent is what the log is equal to, so I can put that over here. That's going to be our 5. And an exponent or log can be negative, and the log and the exponent can also be variables. So now what's the only number that's left is this 343, okay? So this is, we're going to work another one. So again, log, our base is this, so that's going to be the 25 down there, and then I'm going to take this number and I'm going to put it next. And then remember, our exponent is going to be what it's equal to. Okay? Again, log, we're taking this 10 right here. It's going to be our base, log base 10 of 10,000. That's going to be equal to 4. Here again, log, take this right here. It's our base of the 1/6. And that's going to be equal to -1. Remember, that exponent is always going to become what it's equal to on the other side, okay? So this is going to be log, again, base a of c equals b, log of 9, log base 9 of 81 is going to be equal to 2, log base 3 of 27 is equal to 3, log base x of 1 is going to be equal to 0. Okay? Anything to the 0 power is 1, right? All right, now let's talk about doing the opposite of that. So now we're going to write each logarithmic form into an exponential equation. So the base of the logarithm becomes the base of the power. So that means this right here is going to be our 9, right? What the log is equal to is the exponent. So that now becomes our exponent. And that's going to be equal to the number that's left, which is that 9. This 9 right here, okay? So a logarithm can be negative number, and any non-zero base to the power to the 0 power is 1. Okay, so here we go again. So remember, we're going to take this base right here. That's going to be our base there. We're going to take it to this power, and we're going to say that's equal to the number that we had. So it's log base 2 of 512 equals 9. So this is going to be 2 to the 9th equals 512. Okay, so here again we got our 9 right there. We're going to take it to the second power. That's equal to 81. We're going to take our 4 here to the -2. And remember, if it's negative, it's going to go to the bottom, and that's going to be equal to 1/16. Here we're going to have b to the 0 power, and anything to the 0 power is equal to 1. Then we got this log base 10, so of 10. So we're going to say 10 to the first is what? 10. And remember, anything to the first power is itself again. Then we've got 12, again our base, to what power? The second equals 144. And here again, 8, sorry, did that one wrong. Sorry. The 1/2, our base, 1/2, to the what? -3 power equals 8. Okay, and remember, if it's -3 and it's a fraction, you're going to flip it first. So it's going to be 2 over 1, and 2 over 1 to the third power is 2 to the third power, which is 8. Okay, so now we're going to talk about these properties over here to the right. Okay, these properties over here. So I want to go over these. So when we got log base b of b equals 1, why is that way? It's because we're going to take this little b right here to the first, and that's always going to be equal to what? Whatever this base was, because anything to the first power is itself, right? And we're also going to talk about this one right here. So this is going to be log base b of 1 equals 0. So here again, we're going to take this base b to the what power? 0. Anything to the 0 power is 1. So these two are always going to be, so if these bases right here are the same, then it's because that number over there was a 1, right? Or if that number over there is a 1, then those two bases are the same, okay? And then same way down here, if we got a log base b to the 0 power, then it's going to be 1, okay? All right, so now a logarithm with a base 10 is called a common logarithm. So we're going to call this a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. So for example, log 5 is log base 10 of 5. So we're going to use our calculators to evaluate these functions. So I'm going to show you guys this in Desmo, so give me just a sec. Okay, so first of all, I want to show you how to find the log. So we're going to click on the keyboard. We're going to go over here to Functions, then we're going to click on Miscellaneous. And when we do this, notice down here that we have a log with no base, which means it's log base 10, and then we have log with the base. So first we're going to use this one, and we're going to go ahead and put these numbers in here just like they are in our paper. So we can say log of 5, and it's going to give me this answer, 0.699, right? So let's go back. So this is going to be 0.699, and remember we're going to round. Now let's look at the log base 4. So we're going to go ahead and put 4 here. This one's going to be 0.602. So this one's going to be 0.602. And then we're going to do log of 1/10. Go ahead and do that. You should see that that's -1. And then the log of 125 is going to be 2.097. Okay, so on this next one, it says if a logarithm has a base other than 10, you can use the change of base formula to help calculate the value of a log. So when we do this, this is what I want you guys to remember, that the base is low. So guess what? What does that mean? It stays in the basement. Okay, so when we write these, notice our first example here. So we have this 4 is low, right? So it stays in the denominator. So it's going to be log 16 over log 4. Let's show you how that you can do this again in Desmos. So here again, I'm going to go to my functions, going to go to miscellaneous and to log. So I'm going to do log of 4. Close that parentheses, and then I'm going to divide it by, click on my log again of, wait, I did the opposite, right? It should be log of, yeah, 16 over log of 4, sorry. So this should be 16 up here and 4 down here. And when we do that, we get 2. 2 it is. Okay, now I'm going to show you how to write this first before we enter it in the calculator. So again, we're going to put the log 2 on the bottom. Sorry. Let me do that again. Log 2 on the bottom, and we're going to put the log 8 on top. Over here, log 7 and log 343. So once again, go ahead and put these in the calculator and tell me what you got. So hopefully you got 3 for this one. And you should have got 3 for this one as well. Okay? All right, now let's go on and do some of these problems. So here's some more examples. So on this one, oh, let's go back actually. I want to go ahead and talk to y'all about steps to solve for a variable. So we want the steps to solve for a variable. So let's talk about what those are. So our first one, if the variable is by itself. So if the variable by itself, if the variable is by itself, use the change of base formula. Okay, so that's what we just used. Use the change of base formula. Okay, and if the variable is in the base, so if the variable is in the base, then put it in exponential form and take the root. Put in exponential form and take the root. And we're going to do a couple of these. Okay? You can pause this if you didn't get all this written. And then go on with me. Okay? All right, so on this next one, so this one, because our a is, so it's log base 3 of a equals 4, right? So we're going to take our 3 and we're going to take it to this 4th power, and that equals a. So when we do this, this is simply what? Just taking 3 to the 4th in the calculator, and that's 81. So that's the answer to that one. Okay? Now on this next one, remember, this is where we're going to use our change of base formula. So we're going to say log 4, that's going to be, sorry, I wrote that too small. So log 4, that's going to be, stay on the bottom, right? And then we're going to do log 64. So on your calculator, you can do log of 64 divided by log of 4, okay? And this one comes out to be 3. Same way with this next one, okay? So we're going to do log of 5 over log of 125. And again, when you do this one, you should have got 1/3. So always write these first, okay? So on this next one, there's going to be a to the 5th power equals 32. Now this is the one that we talked about as our step 2. If a variable is in the base, put it in exponential form and take the root, okay? So what does that mean? That means we're going to actually take this to the 1/5 power and we're going to take this to the 1/5 power. Because remember, the way we get rid of a 5 is multiplying it by 1/5 because it's 5 over 1. So when you take 32 to the 1/5 power in your calculator, remember you're going to do 32, the caret symbol, and then 1 divided by 5, right? So when you do that, you're going to get 2 for this answer. Okay? So now this next one, again, we're going to do 3 to the 1st. That's equal to a, which means that's equal to 3. Over here, we're going to do log of 1 over log of 10. Okay? And when you do that, you should have got 0. All right, see if you can do these last 3. Pause the video, do these 3, and then come back to me when you're done and check them. Okay, so this is going to be log of 343 divided by the log of 7. This one was 3. Excuse me. This is going to be 8 to the 1/3 power equals a. That's going to be 2. And again, you're going to do that in the calculator. This next one is going to be a to the 5th power equals 243. So this is the one where we're going to, again, take the inverse here of that, or the reciprocal. Okay, so we're going to do 243 to the 1/5 power, and this one was 3. Okay, so you guys should do the 8-2 practice and then take pictures of it and upload it to Google Classroom.